lesson, what we learn is the angle of elevation and the angle of depression. So if you have 2 points, 1 point look up and 1 point look down, and they have the same size of the angle of elevation and depression. So the most important thing for angle of elevation and depression is you must measure the angle with the horizontal, not the vertical. So it's very easy to make the mistake. When you just see there's a vertical line, you say that's the angle of elevation or depression. That's wrong. So it must make with the horizontal. And today we're going to talk about bearings. Okay, so just let you know in advance that bearing can be quite confusing with the thing we'll learn later. We'll talk about the unit circle later for circular functions. That's what I said is in VCE math method. This is kind of a little bit like confusing for you if we learn this one and then we learn the other one. So we must remember we measure the angle from different lines. So for bearing, we always measure from the vertical. Okay, for bearing, we always measure from the vertical. We talk about the bearing. We start to measure from the vertical. Okay, and go for clockwise. Okay, go for clockwise. So we measure angle. Well, I'll talk about how to measure it, but I just talk about like how we should measure it. We measure start. Our starting point should be the vertical. Okay, north. And then go clockwise. That's how we measure bearing. But later we'll talk about the unit circle and we talk about the angle in the Cartesian plane. We will measure from the horizontal and we will go for anti-clockwise. That's why I said it's a little bit confusing. So we just remember, okay, clearly what is bearing and what's the unit circle. Like then after maybe 3 exercises, what we'll learn. So we talk about angle of bearing first. Okay, so bearing also called a true bearing. Okay, also called a true bearing. So we have this T at the back. I'm pretty sure we will learn this. We learn this in year 9 as well. Okay, so we have the T at the back. That means a true bearing. Okay, so give your example. Okay, give your example. For example, which one I can talk about? Let's just see the diagram here. So first of all, we understand the anti-clockwise from the north. Okay, that's how we calculate, how we measure the angle. So from the north and go clockwise. Okay, not anti, go clockwise. So we must use 3 digits to talk about bearing. Okay, if it's 100 something, definitely we have 3 digits. Like we have angle in between, say 0 to 360 degrees. Okay, true bearing can use angle in between 0 to 360 degrees. Then we have 2-digit number and we have 1-digit number. When we have, for example, 8, okay, a bearing of 8, we need to write 008 to give 3 digits. When we have 2 numbers only, like 32, we must write 032 degrees, okay, to give 3 digits. And then we must have the T at the back. So that's all the requirements for bearing. So start from north, go clockwise, and we must have 3 digits, and then we must have the T at the back. So a lot of requirements for the bearing. So how we measure it? For example, we always see this one. Okay, let's see this one. We have an angle point O here and we have a point A here. Okay, we have point O here and we have a point A here. So you need to measure either from O to A or from A to O. That will be 2 different angles. Let's talk about the bearing from O to A. Okay, from O to A. If it's from O, we draw this compass at point O. Okay, this cross at point O. So from which point we draw the compass at which point. And then we connect those 2 points. Okay, we connect those 2 points. So we connect O and A. Okay, connected. So now the compass you draw, you will have north. Okay, you start from north. This is my north. I start from the north and I go clockwise until I meet the angle. Meet the line. Okay, until I meet the line, you connect those 2 points. So from north, go clockwise until I touch that. This angle here I sketch is called the angle of true bearings. Okay, angle of true bearing. So that's the bearing from O to A. Okay, from O to A. We draw the compass at point O and start from the north of O and go clockwise, draw an angle until we touch the line. We connect those 2 points. So that's the angle of true bearings from O to A. And let's have a look from A to O, what's going to happen. So from A this time, you must draw the compass at A. Okay, at A. So this is my from A. So from A. And then I have connect them already. Connect O and A. Now we need to start from the north of the compass I sketch and to go clockwise until I reach the point. I reach that line. So the angle of true bearing from A to O is this black angle here. Okay, it's a very big angle, over 180 degrees or even over 270 degrees. But you can see from O to A is only an angle less than 180 degrees. So there are 2 different bearings from different points. Okay, even though they're exactly the same 2 points, but from one to the other and from that one to that one is different bearing. Okay, it's different bearing. So that's how we measure the bearing. Okay, that's how we measure the bearing. Okay, so that's all the same. Let's have a look. Okay, let's have a look. So for our first example, give the true bearings from O to A. Okay, can you see from O to A? I have connect OA and I have sketched the compass at point O because it's from O, so you measure from that point. So you from the north of that point, okay, start from here, go clockwise until you touch the line. So that is the angle of bearing. Okay, that's the angle of bearing. That's 60 degrees because it's given that that's 30 degrees there. So that's 60 degrees. So we say that's a 060 degree T. Okay, 3 digit and the T at the back. 3 digit and the T at the back. Okay, also I can say for another way, I can say this A is go to the northeast direction. Okay, northeast direction is go to the north, up higher than me, and also at the right for me. So it can, this is not the true bearing, is I use north, south, west, east to talk about it. So I can have northeast, okay, southeast, northwest, and southwest to measure it as well. So you can see this point is here, is north 60 degrees east. Okay, I can also use this way to talk about it. So it's to the north and east direction of 60 degrees. Okay, northeast direction. So it's at the northeast direction and 60 degrees. Okay, at 60 degrees. But that's not true bearing. Okay, this is not true bearing. That's not true bearing. This is true bearing. So you must have the T at the back. That's the true bearing. That's just another way we can say the position between A and O. So A is at northeast 60 degrees from O. Okay, A is at northeast 60 degrees from O. Okay, have a think about the next one. What's the true bearing for the next one? Okay, what's the true bearing for the next one? Okay, calculate the true bearing for the next one, and also you can use northeast, southeast, that notation to talk about it as well. So use 2 ways to talk about the position. Okay, talk about the location. Compare O to A. Okay, have a think. What's the true bearing for that? After you finish, you can have a look. do we have the same answer here? Okay, the red thing I sketch is the true bearing from the north until we meet the line OA. Okay, and then we can also say that from south slightly go east for 41 degrees. Okay, south and go east for 41 degrees. Okay, that's how we can do for another way, but it's not that important for this one. Okay, that's just another way we talk about the location, but this exercise is focused on the true bearing. If you can do the true bearing, that's good enough. Okay, that's just another thing I can just develop a little bit more for you. So that's another method we talk about the location. And then you can think about C. C, that gives me the true bearing. Okay, from the north until we meet that line. So that's 360 degrees minus 71 degrees. So the true bearing is 289 degrees. And north 71 degrees west. Okay, we always start from at the north or south. Okay, we start from north or south. So north 71 to the west, or south how many degrees to the west. So this angle, okay, for true bearing we can have angle in between 0 to 360 degrees. But for northwest, this notation, the angle we only take in between 0 degrees to 90 degrees. Okay, we'll only take 0 to 90 degrees to talk about it. So true bearing, we can go for 0 to 360, but for northwest, southwest, northeast, and westeast, southeast, southwest, we only take angle in between 0 to 90 degrees. Okay, that's the two way we talk about the bearing. Okay, remember the 3-digit thing. Okay, remember the 3-digit thing. It must be 3-digit when we talk about true bearing, and don't forget the T at the back. Okay, don't forget the T at the back. Okay, let's have a look at example 2. Can you sketch a diagram for me to represent the situation? Okay, can you sketch a diagram for me? Where's O, where's B? How we can set up the location for it? Which point you will draw the compass at which point? Okay, so the cross. If it's point O, start from point O, I will draw the point O here. So on a bearing of 160 degrees, that gives me 160 degrees. Start from the north 160 degrees to reach the point B. Okay, to reach the point B. And OB got the distance of 75 kilometers. Okay, that should be a diagram. Well, better we sketch the north. Okay, when we sketch a compass, we sketch the north. So that's the north. Okay, let's have a look at the question. A said, how far east to the nearest kilometers of its starting point of this boat? Okay, how far east? this bolt go to the right and also go below, right? So it's going to the right, it's at the right hand side of point O and also at the bottom of point O. So how far to the east? What we'll do is we will sketch a right angle here, okay, a vertical line here. This purple color is how far to the east. And this black color here is how far to the south. Okay, this bolt travel to the east and also travel to the south. Okay, go to the right and go bottom. So the pink color there is how far compared to O to B. Compare O and B, how right, okay, how far to the right. So it's how far to the east. And then the black color here is how much it travel below, okay, travel below. So that's go to the south. So the black vertical line there is how far it goes to the south. Okay, make this bigger. And also we can see this angle. Okay, what's the size of this angle here? What's the size of that angle here? How much? 70. Good, 70 degrees, because it's 90 above that, 160 in total, so it's 70 degrees. Let's say this point is point A. Basically, I want to try to find the length of OA. Okay, trying to find the length of OA. Okay, that's how far to the east. The length of AB is how far to the south. So what I can do is, I know the hypotenuse. Okay, I know the length of the hypotenuse. And I want to find the length of the adjacent. So what I can do here, A is cosine 70 degrees equals to OA over 75 is the adjacent over the hypotenuse. Okay, that's the cosine. It's the adjacent over the hypotenuse. And we know OA is 75 cosine 70 degrees. (75) times cosine 70. Well, I want approximation values. Okay, I want to nearest kilometer. Okay, nearest kilometer is approximately 26 kilometers. It's approximate 26 kilometers. If I want to calculate how far to the south, okay, how far to the south, I can use the sine to calculate. Okay, I want to know the opposite and I know the hypotenuse as well. So I can use the sine to calculate this. Okay, what is the bearing of O from B? Okay, of O from B. If I make this larger, okay, from B now I need to draw this compass at B. Okay, this, well, hopefully you can see this color. So I draw this from B. Oh, I can't see. I'll use a red color to sketch it. Okay, so I draw the compass at B. But this line is already north. Can you see that line is already north because it's perpendicular to this line here. So the bearing of O from B will be this one here. Okay, will be this big one here. So it's all the way clockwise until I meet this line. Okay, it's all the way until I meet this line. What's the size of this small angle here? What's the size of this small angle? 20? Small one, the small one, this one. Okay, that's 70, that's 90. So right angle triangle, so 20 for this small part. Okay, so 20 here. So 20 degrees here. So what's the size of this big angle then? 340. Good. 340. So for B, the answer will be, okay, it's asking for true bearings. 340 degrees T. That's the true bearing of or from B. Okay, of or from B. So it's 340 degrees true. Any questions so far? That's the type of question. Later on we will learn sine, cosine, and sine rule, cosine rule, and area of triangle, and then we'll use this bearing to combine that definition to talk about more application questions. So you might have this either in your homework task or maybe in the application task. So it's a very good combination for sine rule, cosine rule, and this bearing concepts. Okay, let's have a look at 3. So I will do first 3 parts with you together, and I'll give you time to do D and E by yourself. Okay, I'll do D and E by yourself. So let's have a look at 3. A hiker walks on a triangular path. Okay, starting from point A. Walk to point B. Okay, can you see from A to B is on a bearing of 140 degrees. Okay, on a bearing of 140 degrees from A to B. And then B to C. Well, that's not a bearing of 75. So B to C. Then A back to A again. Okay, back to A again. Okay, let's have a look. Oh, let me ask you a quick question. You don't have this in the part. Well, maybe we write it down. What's the bearing? Okay, what's the bearing of A from C? And what's the bearing of C from A? Okay, C and A, they are on the same line. Okay, it's the same perpendicular, like vertical line here. Quick question. What's the bearing of A from C, and what's the bearing of C from A? Let's do this one first. Let's say that's I and I. What's the first one you think? Okay, well, I can say two ways. I can say that's 0 bearing, or I can say that's 360 bearing. They're the same thing, because it's either no angle at all or go around, like go a full circle. Like that's, I can either be 0, well, maybe I would say 360 degrees true bearing because 3 digit. Otherwise, I would say 0, 0, 0 degrees true bearing. That's quite weird. I can say that's a 360 degrees true bearing, but they normally don't ask you questions like this. But now let's have a look. What's the bearing of C from A? What's the true bearing of C from A? 180? Anyone disagree with that? Or everyone thinks 180? Okay, it is 180 degrees. Okay, so from A is from here. Okay, you connect the line. So that's your true bearing here. So it's 180 degrees. Well, this 2 questions is very easy, but like sometimes you may confuse with it, like can't see it. So better to talk about that. Okay, so for the perpendicular ones, like just above that or below you. Okay, just above you or below you. That's either 0 degrees or 360 degrees above me, or it can be a 180 when it's below me. Okay. Now let's have a look at the first one, A. Find the bearing from B to A. Okay, from B to A. let's draw a really, how can I say, a large compass, okay? Let's draw a one like this. Let's draw a big one. Because you know if you extend this, this will be perpendicular. You know that? Because it's south, northwest direction, and this is north and south, and this is west and east, so that will be perpendicular. So that's the north as well. I want to find the bearing of A from B to A. So from B to A, so connect BA, and I have this bearing here. Okay, I have this bearing. It's a really large bearing here, over to 70 degrees. So it will be 360 minus this bit. Okay, minus this bit. Can you see the size of that one? Yeah, what's the size of that? It's 40 degrees. Because here is 40 degrees, and that's the alternate angles, parallel alternate angles. So that's 40 degrees as well. Well, for bearing question, you need a little bit like looking at the graph and trying to find parallel lines. Okay, trying to find parallel lines and find the angles. So that's the alternate angle. So that gives you 40, then that will give you 40 as well. So then the rest of this will be 320 degrees. Okay, 360 minus the 40. So this will be a 320 degrees. Okay, 320 degrees. And my habit of doing this type of question is I want to label all the angles that I know. Okay, all the angles that I know. Okay, it's hard to give a lot of letters, but can you tell me what's the size of this angle? $15. Okay, 40, 50 give you 90. And what's the size of this angle here? $25, yeah. So this small angle is 25 degrees. Okay, because 75 minus 50 gives you 25. And what's the angle for this one? Calculate again. 65, good. That's 65 degree. Okay, that's 65 degree. Because I can say that's a 90, so those two should add up, give you a 90 as well. So that's a 65 degree. Well, I don't know what I want to calculate yet, but it's good to label everything that I know. Okay, it's good to label everything that I know. So after I label everything, question should become easier. Okay, should become easier. So what's the bearing from B to C? Okay, from B to C. Okay, from B to C. So I will connect BC. So it will be this angle here. It will be this angle here. What do you think the size of this angle should be? $245. How do you calculate that? 180 plus 65. That gives you 245. Yeah, that's one way to calculate. Anyone else get any other way to calculate? That's one way to calculate it. That's true. Can you see any other method? Similar method. Yeah, 360 minus which one? Yeah, minus 75 and minus the 40. That's one way. Any other way? Should see another one. I can use 270 minus 25. Yeah, I can use 270 to minus 25 as well. So they're all correct. Okay, they're all correct. What I want to show you here is you can use multiple ways to calculate the bearing. Okay, adding or subtraction, like they all works. So you don't forget each section is 90 degrees. Okay, each section is 90 degrees. So up to the black line there should be 270 minus the little bit, so 25 degrees. That should give you 245 degrees. Okay, so I have 240. I forgot something before. T. Don't forget that. The T. Okay, don't forget the T. So true bearing, we need the T at the back. Okay, last one is the bearing from C to B. Okay, from C to B. Alright, from C. Can you tell me immediately what's the bearing from C to B? 65 degrees, true. Okay, 065 degrees, true. Okay, 065. So from C to B is from the nose to this point. So it's 65 degrees. Okay, the angle we calculate already. That's why I said label all the angles you know first, and then it's easy to see what they require later. Alright. If you don't have any questions for this, I give you 10 minutes to figure D and E. D and E, the angle changed. I want you to sketch two different diagrams for me, one for D and one for E, and then talk about the bearing they're given. Okay, I'll give you 10 minutes to do that. Okay, I think everyone, most of you maybe get a little bit confused with the last one because the diagram looks a little bit different. If you think about the first one, it looks pretty much the same as before, like exactly the same shape. We have 133 on top and have 47 here, and that's a 75. If I draw a horizontal line, I have 43 and 32 here, which gives me a 75. So the bearing from B to C, it gives me 270 minus 32 minus this part, and I get 238 degrees true bearings for part D. Okay, I think most of you get this one. But the trick for the next one is the angle ABC becomes 42 degrees. It's not large enough to go beyond this horizontal line. Because if you draw this horizontal line here, that's a 50 degree. Okay, that's a 50 degree. So you only go for 42 degrees. You have 8 less here. Okay, you go top instead of go down here. So that's why the shape looks a little bit different. And the bearing will be 270 plus this 8. Okay, the 270 plus this 8 instead of subtracted. Okay, so that's why we have a true bearing of 278 degrees, which is larger than this one. Okay, which is quite larger than this one. Okay, look at this diagram. Because it's 70, not 75, it's only 42. So it's not enough to go below here. Must go up. Okay, must go up. Compared to B, it's increasing. Okay, it's increasing like in vertical. That's the difference between this one and this one. It's a little bit tricky. Anyone got questions? Anyone got problems with that? Okay, if you don't have any questions, you can either try, well, this is a book question. You can see this on the textbook as well. Or you can just skip that one, directly go to your homework exercise. Okay, this question should be in the homework as well.